Okay, lecture 21, molecular mass and formula mass. And you should know these definitions. Now, calculate the formula mass of each of the following three significant figures. Now, if you've looked at the definitions, you know that molecular mass applies to molecules. Formula mass applies to molecules and ionic compounds and ions. So it covers everything. That's why we usually use formula mass. So if you say, what is the molecular mass of sodium chloride, that's incorrect. People will understand what you're talking about, but that's not the way to do it. So calculating the formula mass, and remember we're dealing in AMUs here, because we're trying to find, when you talk about the formula mass, you mean the mass of one molecule or one formula unit at a time, so we deal with AMUs. And in the periodic table, those numbers underneath these symbols are the atomic masses, and those are the ones that we're going to use. So for methane here, CH4, we have one carbon. So that is 1 times 12.0107. Now, I'm going to use all of the significant figures just to make a point that you don't need them all, especially, well, it depends on what they're asking, but normally you only need about 3 significant figures. Sometimes people go out 4, but in this case they're asking for 3 significant figures. So, but let's say we just use everything, and we have 4 hydrogens. All of the significant figures are used, so this is 1.007. Now, I'm going to take a shortcut here. You multiply through by 4. We end up with 16.04246 AMUs. And we'll have to cut it off here because we need 3 significant figures, so that's our answer. Now note, if we would have started with 3 significant figures, see if I have room on this side, made this 12.0 and made this 4.04 AMU, we're at 16.04, and hydrogen, to have 3 significant figures for hydrogen, we have to go out to the hundredths place. For most of the other elements, we only have to go out to the tenths place, and for some of the larger elements, we go to the ones place. So you can see we end up chopping off there as well. Now here's another even briefer way of doing it. For hydrogen, I generally, just to save some time and energy, I use 1 AMU. It's approximately equal to 1.01 AMU for hydrogen. And now if you're really picky, you can certainly do that. Get carried out to 0.01, but you'll note that most of our answers are going to have the tenths place or the ones place, so that 0.01 is going to be lost. So I tend to just use 1 AMU. Now be careful, 1.00 AMU to make things a lot easier in the calculations. That's me. You want to check with your instructor, whoever you're taking, and as you go into other classes, see what they want. But for me, I find that try any of these calculations with 1 AMU and 1.01 AMU for hydrogen, and when you round it to 3 significant figures, you're generally going to find that it doesn't make any difference. Okay, now here we are for calcium. We have 1 calcium. This is 40.1. Taking what is 40.078 and reducing it to 3 significant figures, because that's where we're going to end up anyway. That's what it's asking us to do, is find 3 significant figures. Then we have 2 chlorine, and so that's 35.5 AMU times 2. And then we have, looking at make sure you take into account both subscripts here. It's this is the chlorate ion times 2, because of that 2 there, so that's 6 oxygens, so 16 AMU, and oxygen is 15.9994, so 16.0 will do. So it's all a matter of how many significant figures you need to deal with, and when you add this up, we end up with 207.1 AMU, and we can see even here, because we've gone out to 207, and it asks for 3 significant figures, we even cut away the tenths place. And always an AMU, because for the formula mass, that's what we're figuring out, is the mass of one molecule or one formula unit. Now, just to make life simpler, and there's no reason for me to go into these any further. I'm going to just rewrite them, make sure that they're large enough, bold enough to see. These are the answers to these formulas. And try to get these. You should have a pretty good idea of what you have to do now. And the only tricky thing here is there's hydrogen here and hydrogen here, so make sure that you take into account all the hydrogens. And these should be your answers. So do these out and just to verify those.